Welcome to day 3, everybody. Let's get the ball rolling quickly without wasting time. Um, we're just going to run in through some questions as quickly as possible. As quickly as possible. All right, guys, we've done quite a lot of things already. We've covered the concept where we said everyone must get marks. Those concepts have been covered. All right, so today let's play around with our circuit and momentum as fast as we can. If we can get this done quickly, we can add more. All right. So I'm going to start with circuits very fast. The main thing about circuit, what do I need to remember? Apart from your definitions, guys, definitions is all on you right now, right? What should I be able to define? Be able to define what? Voltage. Yes, for me, we should be able to define what? Okay, let's say potential what? Difference. What else? Current. Resistance. Ohm's law. you were wondering. Ohmic conductor. Ohmic and non-ohmic conductor. An ohmic conductor is a conductor that obeys Ohm's law. All right. And a non-ohmic will not what? Obey. What else are we defining? EMF. And please be able to define internal resistance. Internal resistance is the opposition to the flow of current within the battery. Take note of that. Internal resistance is the opposition. Hi, Ricardo. Hi, Frederick. It's the opposition, because generally resistance is opposition to the flow of current, right? But when I say internal, then you add the clause to it, within the battery. So please take note of that. And we are now, you should also be able to do your calculations. And what do? We use SAPD, is paid. I hope you remember what it means. Series are potential what? Dividers. Parallel are current dividers. You get that right, all your definitions, all your calculations are in place. Series are potential dividers. It means when we have resistors connected in series, potential difference is divided. Current would remain what? The same. But when we have them connected in parallel, what is divided? Current is divided. But potential difference will remain what? The same. Okay, let's see. 2 questions quickly here, and then we move on to momentum. But I'm going to see, I need to do a graph question on this, also a graph on photoelectric effects. All right, look at this very quickly. Grade 12 learners are conducting an experiment to determine the EMF and the internal resistance of a battery. They have access to an ammeter, but do not have a voltmeter. The setup is as shown in the diagram below. Look, the first thing you need to do is to quickly check how your resistors are connected. How do you check that? Trace the flow of current. Current will always move from the positive to the negative. So I'm going to come here, positive, negative. Current is moving that way. All right. Do you notice the current has not done anything? Passing through A means I'll be having what? I total. When that current gets here, what happens now? It splits. And when it splits, it becomes what? A parallel connection. 1 second. Hello? I'm all right on yourself, sir? Okay. So when we get here, current is splitting. It means these two are now connected in what? Parallel. And we know what we're going to say here is what? Paid. Make sense? Now, what happens here? So current goes here, current goes here. What happens here? It's going to combine. And when it combines, what would I have? My I what? Total. It having I what? Total and back. And what will I have here? I what? Total. The total current must always pass through the internal. Right, define the term EMF of a battery. Oh, that's one of the things we listed a while ago, right? So what's the EMF? It is the maximum energy that a battery can what? Supply. So take note of that. EMF is the maximum energy supplied by a battery. Maximum energy. So your battery supplies energy that moves the charges. State the purpose of placing the switch next to 8 ohm resistor. Now let's try something. Guys, if I leave this connected like this, how many resistors do I have working? Are connected in what? Parallel. And this parallel is connected in series to that. Are we okay? But if I open the switch, what do you think will happen? I have my switch opened. Yes, what do you think will happen? Let's call this A and B. Resistor A, resistor B. Something's going to happen. What will happen? Talk to me quickly. The faster you... A is no longer working. Current will only flow in resistor what? B. Start walking through the question. So what is actually controlling the value of the total water? Okay, please do me a favor, everybody. Let's do some quick calculations. When the switch is open, please calculate the total external resistance. Switch is open. Come quickly, I need you. When the switch is open, open switch. What is R total? Guys, there's no need to even calculate there. Because once the switch is open, what are we saying? We are saying this guy is no longer working. So how many resistors do we have? Current would come here and go here, right? Now, what type of current is going here? I total. Again, I, it means this and this are now connected in series. So what would that value be? 8 plus 0, 4, which is what? 8, 4 ohms. All right. Closed switch. What do you notice? Those things are now connected in what? Parallel. How to calculate the total resistor in parallel? If there are 2 of them, we can just say product over sum, or we use our normal 1 over. So can I say that R total will be product a sum plus R0, 4. Does that make sense? Because that block is connected in what? In series to the 0, 4. Our product, 8 multiplied by 8, 8 plus 8, 0. Why am I writing equals to? Plus 0, 4. That gives us. So just by closing and opening the switch, do you notice we are changing the resistance? So the switch is placed there to allow us change what? The value of the resistance. Very clever. It's placed there to allow us change the value of the resistance. Are we okay, everybody? All right, let's go and do the main calculations now. Write quickly if you want to write. Fast, 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 fast. Don't. Okay. Now, it says the result of the experiment are shown in the table below. Open, the ammeter reading is 4 amps. When the switch is closed, what are we looking for? Internal resistance, 5 marks. Use the result for the experiment to determine. We should use that formula, so we are restricted. Okay. I into bracket R, but let's see. Open. Yes, your EMF is going to remain the same though, because we're not changing the battery. So do I know the value of the EMF? No. But do I know the current when the switch is open? What is it? 4. What does this capital R stand for? External. Oh, do I know the value of the external resistance when the switch is open? What is it? 8,4. Guys, I need you to speak so that I can know that we are on the same page. 2 unknowns. When we have 2 unknowns, simultaneous. Okay, so let's go check for when the switch is closed. E, what is the current? Can I ask you a question that an examiner like me would want to ask you before I even jump to the calculation? Why did current increase when the switch is closed? Open, it was 4 amps. When the switch is closed, it was 6. Did we add extra battery? Because I don't know where that current is coming from. Can somebody please explain? When the switch is open, it says current is 4. But when the switch is closed, current is 6. What is responsible for that increase in current? Yes. Angelique says internal resistance. No. Not internal. Not internal resistance. Not internal. Not internal. Anybody? External resistance. Why? Let's go back to the circuit. Okay. I'm listening. Alex, guys, I'll voice over what is saying. Yes. Okay, 1 second. Just 1 second. Okay, Frederick, hold on. Effect of the total resistance. Okay, shoot. Okay. What is the relationship between resistance and current? Inversely proportional. Do you notice when the switch is open, what's the value of the resistance? 8,4. But when we close it, what is the value of the resistance? What happened? It decreased. If resistance decreases, what happens to current? It will increase because they are inversely proportional. Did that make sense? So when the resistance is high, current will be low. When the resistance is low, current will be high. So take note of those tiny little things that examiners want to test you on. What is the relationship? Current and resistance are inversely proportional. Thank you, Frederick. You also gave me the effect of the total what? Resistance. Okay, not revive this time around. Revive will affect the external voltage. But the examiner is not asking for the external what? Voltage. We are dealing with current. We are dealing with current. Okay. What is my total resistance when the thing is closed? 4,4. 4,4 plus what? R. Guys, equation 1, I need you to work with the speed of light. Please answer 8.3.1 for me and 8.3.2. Quickly. Simultaneously now. Speed of light, I'm giving you a time frame of how many minutes? 4. Just simultaneous now. We don't want to waste time. But please don't calculate EMF first. Analyzed. Calculate internal resistance first. There is the voltage and internal, everything works together. Everything, but it is connected. I'll remind you of how the connection works. Get me the calculation. Done? Else is done? Your answers quickly. There's a 3,3 ohms. Okay, covered. All right, 3,6 corrected, and 48. What are you getting? Hmm? Run. Get EMF. Increase the pace. This one is actually quite straightforward. Because if I'm looking for internal resistance, I'm going to eliminate E. So I can just equate them. Can't you? What are you getting? Come on, Robbie. Time. That is free 7 marks. Right, lovely. Good, thank you. You have your EMF now. Get the R, get the small R. But why are you getting EMF first though? Don't get EMF first. Let's follow because you cannot use 8.3.2 to answer 8.3.1. How can you use it? So when now you wear your uniform before taking your bath. Which different situation? No, it's a sequence of events. Step 1, wake up. Step 2, get off the bed. Step 3, make the bed. You make the bed before you get off from it. Yeah, it's personal. All we need to do is just to equate, right? So what do we have? 4, 8,4 plus R would be equal to what? 6, 4,4 plus R. I'm sure we can do this. I don't need to. We just expand if you want to expand. I'm sure you did. That's what you did. Proudly so. Okay. What is 8 times 8,4 times 4? 16, 32, 33,6. Okay. What's wrong? I'm not. It's just natural. It's just natural. 4,4. Oh, okay. All right. I'll stop flexing. I wanna flex, my love. Yes? Yes, I'm listening. Hello? Hello? You ain't talking. All right, 4,4 times 6. What would that give us? 26,4. What's the story? You think I won't be able to? Okay, please talk. Or please send a message if you're having a challenge with your mic. 33,6 minus 26,4. 7,2 would be equal to what? 2R. So what is R? 3,6 ohms. We are done there with 8.3.1. But remember, somebody's going to say, is this all 5 marks? Calculating those resistance as well is part of the marks here. Now, what about the EMF? Easy, right? We have 4 into bracket 8,4 plus what? 3,6. What did you say your answer is? 8 volts. We're done there. Okay. Calculate the power dissipated in the battery. Look, my dear learners, always just listen to what they're asking you. Power. Examiner wants what? Power. Where? In the battery. When the switch is what? Closed. How do you get power? How do you get power? Okay, everybody, your formula page, quickly. They said in the battery when the switch is closed. Don't forget what you have. When the switch is closed, what is the current? It's closed. I is equal to what? 6. That's fine. I is equal to what? 6. We are looking for what? Power. Go and check your formulas. P equals to IV. P equals to I squared R. P equals to V squared over R. You have a lot of formulas that you can use. I'll give you, it's 2 marks. 2 minutes. I want to see what you will do. Huh? Why? Why? What's your answer? What did you do? Yes. What formula did you use? Okay, you know what I'm going to ask you to do? I want to look at this. I want to look at the corrections at once. So please, let's do 8.4.1, 8.4.2, and 8.5 quickly. Let me give you 6 minutes. Quickly. 5 minutes. Yes, hands raised. Frederick, your hand is raised. Please use your formula page. Let that be close to you. I told you when they say energy, you are using what? W. Current when the switch is open, 4.
Use akekho.
Okay, are we done? What was the message? All right. Um, the examiner would always guide you. There's a focus. They said in the battery. So what do we know about the battery? Do we know the current in the battery? Yes. Do we know the internal resistance in the battery? What is the internal resistance? 3,6. Oh, so we are done. P therefore is equal to what? I squared R. What do we have? 6 squared multiplied by what? 3,6. What's your answer? 129,6 watts. We're done, guys. That's how to work your things. Huh? Why would they said in the bed, and I kept emphasizing. In the bed. So you use. Can we try something? What's our lost vote? Wait now. 21,6. Are you sure? Okay, let's try to calculate our lost vote. What's our lost vote? Lost vote is actually calculated as V equals to what? IR. Is that fine? Look, we are wasting time though by doing all of this. Because power is equal to I multiplied by what? V lost. Why? We are dealing with in the battery. What is your V lost? I multiplied by R. What is I times I? I squared multiplied by R. We're coming back here. So when they say in the battery, use all the information that has to do with the battery. If you, but always write the formula. Always. Always write the formula. That is teacher dash. That is teacher dash. All right. Energy dissipated. I told you when they say the word energy, we are referring to what? W. Is that okay? Energy. So we are looking for W dissipated in the bulb in 6 minutes. What is my time? 6 times what? 60. Remember, we always convert to seconds. Okay, you girls are talking now. 360 what? Seconds. When the switch is open. When the switch is open, which resistor is working? Is it A or B? B. So the examiner is referring to what? B. Do we know the resistance? Yes. What's the resistance? 8. So the questions are very clear. R equals to what? 8. This one is 3 marks. Okay. Sorry? No. Actually, the resistance is not 8. It's 0.4. Because they said the bulb. All right. The bulb. When the switch is what? Oh, now, what do you know about the bulb? 0.4 ohms. What type of current goes in there? It's the total current. When the switch is open. When the switch is open, what's my current? 4. Guys, can you see that all the information are just there? You just need to pick it well. I equals to what? 4. Is there a formula? Yes. What's your formula? W equals to what? I squared R delta T. What is my I? 4. What is my R? 0.4. What is my T? 360. What's your answer? 23. And what's the unit? Joules. Guys, we are done. So focus on the resistor the examiner is giving. Are we together? Focus on it and write all the information about that resistor, and then you do your substitution. 8.5. How is the brightness of the bulb affected when the switch is opened? How is the brightness of the bulb? State brighter, dimmer, or no change. Can we go explain and let's go look at it? All right. When the switch is opened, what's going to happen? Once you see a question like that, start with resistance. Will the resistance increase or decrease? It will actually increase. I'll help you with some notes that I gave as well on when to know if resistance is going to increase. But even if you don't know, check. When the switch is closed, what's our value of our resistance? 4.4. When it's open, what is it? 8.4. Is that making sense? So what's the first thing? Resistance will what? Increase. What happens to current? Current will decrease. If current is decreasing, the power in the light bulb will also what? Decrease. If it decreases, the bulb becomes dim. It's a sequence of events. It's a sequence of events. So, check. I'm going to start by saying dimmer. And what are the reasons? Total what? Resistance. What did we say? Increases. Try to give the examiner a formula. But R is inversely proportional to I. Therefore, I will what? Decrease. That making sense to you? But P equals to what? I squared R. Do you see I'm using formulas all through? If my current decreases, what happens? The power will what? Decrease. And if the power decreases, the bulb is going to be what? Dimmer. Check. No one can say you don't know physics. You need to mention power though. Yeah, that's where they can want to start stealing 1 mark from you. Um, how would the what would happen to the voltage? Never. The voltage. Okay, if you want to use voltage, what are you going to say? Total resistance increases, right? Lost volt will what? Sorry. Total resistance increase. Current will what? Decrease. Lost volt will decrease. V external will increase. So if the voltage increases, you are saying, what does it mean? More energy is available. But this is a lot. This is, um, wait, hold on. If more voltage is available, let's check something. Very tricky. I'm just thinking that we are dealing with more than one resistor. We are dealing with the 8 and the 0,4. The 8 is going to chow more. Let me explain that quickly with you guys. That as voltage, as resistance increases, voltage actually increases. A very simple one. Check your iron at home. Look at the wire, the thickness of the wire of your electric iron. Why are we having a different thickness as compared to the wire of your charger? The wire of the iron has a higher resistance so that it can withstand the energy produced because it's a lot of energy. So the higher the resistance, the higher the voltage. Make sense? Your iron spoils at home. You can't say, no, don't worry, Daddy, I'm going to fix it. Then you bring your charger cable and connect that. Can I have your cable? You connect it and then plug it to the iron. You are worse than ESCOM. Is that okay? But I think this answer just makes sense. You just get it done. Is that okay? All right. Can I just quickly, those of you that were with me yesterday, I gave some notes. When will R increase? When will R external increase? And I remember we did this as well. Number one, when you add a resistor in what? Series. Do you remember this? Addition of a resistor in series. Number two, a removal of what? A resistor in parallel. Number three, increase the value of any of the resistors. Once you do any of these three, the value of the total resistance will increase. Value increases. All right. So if the value increases, what happens? Current will decrease. Lost voltage will decrease. And the voltage external will what? All right. I remember giving you that note some time ago. 5. R, resistance, decreases. Current will what? Increase. Lost voltage will increase. The external will what? Decrease. That's 4 marks. So the question would be, do you know whether resistance is increasing or decreasing? And if you are not sure, just do a calculation. Just put values and check. Okay, if they remove this one, I'm not sure, but can I just use my values? All right. Everybody okay? Those of us at home, are we okay? Can I get response? We need to move as swift and quickly as possible. Those of us here, are we good? We good? Can I move? Okay. Oh, so we're done with that one. The diagram below shows a circuit with battery of EMF 12 volts and internal resistance R. The battery is connected to resistors of 25 ohms, 20 ohms, 5 ohms, and resistor X of unknown resistance. The ammeter switch and conducting wires have negligible what? Resistance, while the voltmeter has a very high what? Resistance. Please take note. Voltmeters have high resistance. They cannot be connected in series. Voltmeters have a high. There's a question I want to do quickly. I do that before this or after this? I hope I find it. It's in my head. I hope I find it. Most likely, I'll find it. When I look at the question, I'm browsing quickly which year, which province, as I'm talking to you. There's a processor. I hope I find it. All right. Voltmeters must be connected in what? Parallel. Ammeters must be connected in series. If an ammeter is connected in parallel, it short circuits the whole thing. I did explain short circuit. Short circuit is when you create a pathway of zero resistance. Short circuit, when you create what? A pathway of what? Zero resistance. By current, I should explain. Okay, that's what we're about to do. Current will rather pass through you than pass through a light bulb. If I put your hand in a socket right now, this light bulb will go off. Do you know why? Current is doing a lot of work there. Guys, there's a lot of work going on. The light bulb is hot. That's a lot of work. You are not going to be hot. So current will realize I have two options. Should I go to a place where I'm going to be doing a lot of work? Or should I go to a place where I'm not going to be doing a lot of... Its effect, it doesn't matter. It's just... Yes. So when current gets to a point, it asks. That's why when a resistor is... Guys, check this. Look at this. Oh, beautiful. 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 You know, when I get into this zone, I become something else. Guys, what is the value of the total resistance here? 30. Current is going to come here, moving from the right, right? Get here. Realize there are two options. Should I go where they give me 20 homeworks at school, or a place where they give me 30? Where would you go? 20. None. I see that. Now, that none is the short circuit. So if I have a light bulb like this, check here. I have a light bulb. And I put a wire here. Current would get here and stop and think. If I go through a light bulb, I'm going to be working. But there's a wire that does not have any zero homework. All the current would go there. What happens to this light bulb? It will be off. If you remember, I tried to use the seat belt light in the car to explain this. That when you sit down in the car, you're actually closing the switch. This is the switch. If I were to create a switch here, you're sitting down. It's pressure. That pressure does what? Closes the switch. Is that fine? So what's happening? You are not putting the seat belt. Do you notice the light is on? Sometimes it's the alarm, because the circuit is now what? Complete. When you click that your seat belt, what you're doing is you are creating what? A short circuit. What happens to this? It goes off. Very beautiful technology. That's a short circuit. Make sense? All right. So current will always travel in the path of lowest what? Resistance. So if I check this, 20 ohms and 30 ohms, where will more current go through? The 20. Because they are inversely what? Proportional. Are we okay, everybody there? All right. I'm tracing current quickly. Please always do that. Makes your life easy. When current gets here, do we notice that it splits? And once it splits, it becomes what? Parallel. South African Police Department is paid. Parallel are current what? Dividers. It means the potential difference remains the same. In the meantime, current is divided here, right? What happens here? It combines again. So what will be going through the A1? I what? Total. You need to be able to see what goes on through A1, A2, A3 when they have so many ammeters. You need to know which one gives you the combined. Current is going to go through, and then what do you have here? I what? Total. Guys, is my explanation making sense? It takes you about 30 seconds, 45 seconds to just analyze that in the exam. Somebody's thinking, my time. You are going to suffer down the line. But you do this, you are going to enjoy. All right, what is meant by an EMF of 12 volts? What is meant by that? They are simply asking you to define EMF. How did you define EMF again? Maximum energy that the battery can what? Supply. It means the battery can supply 12 joules, a maximum. Can supply a maximum. That word must be there. A maximum of 12 joules per column of charge. Take note. The battery can supply 12 joules. There's a video I did on YouTube. Please remind me. I call it the voltmeter. That link to you. You need to go watch it. That if I put a voltmeter here, I really measure it. I'll just do a quick 30 seconds shortcut for you, but please go and when electrons are flowing from the negative to the positive. Current is flowing from the positive to the why? Electrons are negatively what? Charged. What's going to happen here? Repulsion. Please, what happens? Your electrons goes to the battery to collect energy. For example, if I have 12 volts, this electron is going to go to the battery and be filled with what? 12 joules of energy. I'm going to come here. What does it have? 12 joules, right? What is this? A resistor. Resist is to oppose. That means it's going to try to move through this. By trying to move through this, it's working. Some energy will be lost. When it comes out here, it will probably have what? 6 joules of energy left. Or let's say 7 joules of energy left. Making sense? It entered there. My diagram is actually wrong. It entered there with what? 12. Now coming out with what? 7. Energy. Has it lost? 5. This is what your voltmeter will read. 5 joules per column. Work done to move a charge. That's the definition. Voltage is work done per unit charge. So it means from here to here, we have spent what? 5 joules of energy. That's what this thing is giving you. Go through. There's a question I did with that if you don't understand this, you will not be able to answer. You don't understand what I explained here. The question is attached to that video. If you don't understand how a voltmeter works, there's no way you are going to be able to answer the question. So I called it the voltmeter. Remind me, I'll look for it and for. Okay. So guys, are we okay with EMF? It's the battery can supply a maximum what? And you guys wrote it down. Maximum energy of 12 joules per coulomb of charge. That's what EMF means. All right. When switch S is closed, the reading on the ammeter A2 is 0,2. Please go to your diagram. It is closed. Can you see A2 there? Write what you know about the value. It says 0.2 what? Amps. By the way, your 25 and 5, how are they connected? Series. Is that fine? Bless. What's going to happen? Potential difference is divided, but current remains. So it means the current here is what? 0.2A. The current here is what? 0.2A. That question I want to introduce. And the reading on the voltmeter V2 is 5.5. Where is V2? 5.5 what? Volts. Look, by looking at this diagram, just writing the things, we are done with this question. Are you aware that the only thing missing here equals to what? IR. Please get me an answer. V equals, use your formula page. 25 times 0.2 would give you what? 5 volts. So 5 volts. Make sense? 5 times 0.2. 1. 1 volt. Do you see that the voltage is divided? Why is it divided? They are connected in what? Series. What is the total voltage on that line? 6. So in this place, I've got what? 6 volts. But this line and this line are connected in what? Parallel. What do I know? Parallel are current dividers. What's constant? The voltage. It means here I also have what? 6 volts. What is missing? Current. Can you see how we just moving? What is missing? Current. V equals to what? IR. What is my V? 6. I multiplied by what? 20. 3 over 10, 0.3. Understand the whole circuit. I am done with this question. When current is coming from here, let me use a highlighter. When current is coming here, ta, 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 we don't know the amount, right? But what type of current would pass through here? It's the total. It has not been divided. When current gets here, it divides. What's the value of the current that goes through this line? What's the value of the current that goes through this line? So what is the total current? So the total combines and goes through here, which gives me what? 0.5 what? Amps. So a quick analysis of your circuit, it's not you wasting time. It's you solving the whole question. All right. Reading on ammeter A1, done. What's our answer? 0. You understand how we got the 0.5, right? Okay. You just write exactly what I wrote down. 0.5 what? Calculate the resistance of resistor what? X. Go back to your diagram, everybody. Do we know the current that now passing through X? We said it's the total. What is it? 0.5. Are you aware the only thing missing is resistance? What's your formula? V equals to what? IR. Do you know your V? 5.5. Do you notice that it is easy when I write all the information that you are just speaking it now? But you are going to be smart. You don't want your question paper to be dirty. Everything is neat, neat, neat. Dirty, your OCD is not going to allow you to calculate. Yay. Please. Once I have it written there, everything, I'm just picking values now. I'm not even calculating. You are the one doing it. V equals to what? IR. 5.5 equals to 0.5 multiplied by R. What's your R? 11. We're done. 11 ohms. Calculate the total. This one we're now playing. Total external circuit. Yeah, this one. Can I ask you to do the calculation for me quickly? Please calculate. This one is 11. Let me draw it out for you. Let's check. We've got 20. Please, everybody. 20 ohms. 5 ohms here. 5 ohms here. Have 11 ohms here. Please, everybody, quickly, you've got 60 seconds. Calculate the total resistance. Very fast, girls. For 60 seconds, you must have an answer for me. Somebody give me answer from the online. Matidiso, please give me an answer. Again, I need answers. No one must give me a wrong answer. The answers must be the same. $23 ohms? 23. Okay. Can I move on? Are you sure? Because what would you have done? I have to first combine the 25 and 5 to give me what? 30. Then I would say those two are connected in what? Parallel. Product over sum. 20 times 30. 20 plus 30 plus 11. Wait, let's go back to what we said earlier on. What is the current flowing through the 20 ohms? What is the current flowing through the 30 ohms? 0.1 with the higher resistance as the lower current, confirming that they are inversely what? Proportional. Sweet. Come on. Calculate the internal resistance of the battery. Like, really? We have the EMF. What's the EMF? 12. Guys, equals to I into bracket what? R plus R. What's the EMF? 12. What's the total current? Guys, everything here has to do with total. What's the total current? What's your total resistance? 23. Plus what? Really? Answer is 1. Plus 12 divided by 0, 5. 24. 24 minus 23. 1. This issue of expanding. 5 times 23. That will give us what? Whatever that will give us, 46. Plus 0, 5 R. Then we move that higher. Resistor X is now replaced by another ammeter. Wait. Let's go back. There's a statement we always neglect. What is the property of an ammeter? An ammeter has negligible resistance. I once explained the word negligible to you, if you remember. Negligible means something you can do, something you don't even want to consider. Here when I explain negligible, okay, this is how I explain it. If I'm invigilating you on Friday, actually be scared. You'll be nervous. Now imagine I'm invigilating you, but I'm coughing. But right now, I'm coughing next to you. It's not, the first thing is, oh, my answer is wrong. You think it's Mama give us a signal. And there's no signal. I'm not giving you, and I just hit your table. You know, invigilators, we do that. We're invigilating. Sometimes we get tired. I just hit your table. You go like, oh, shall if it's multiple choice, I wrote. Maybe you just finished writing A. You go like, yo. Do you know that even before you think, you cancel it? Maybe you are going to then rethink, hey, but this answer is A, but say. But if your Isi Zulu teacher is invigilating and coughs by you, amen. Can you please shift? Okay, Kuvaria, I'm not going to be invigilating. And if I invigilate, please, if I cough, it's just a cough. I am not saying anything. I'm not even going to, when I invigilate, I don't even want to look into your eyes. Because if I look into your eyes, you're going to miss the things you're doing. You're going to just, at that moment, shiver. Because once I do this, especially if I'm and I do this, like tap your table, tap tap tap. You're like, yo. Ah, the answer is C. 3 times. A B C. All right. So the word negligible means to neglect. Is that okay? So if an ammeter has negligible resistance, it's almost saying it has what? 0. When I come to this, I don't want to forget something. A teacher sent a question on my teacher group. 1 second. Yeah. Wire here. Question is, what is the reading on the EMF is E. R. What is the reading? 0 or is it E? Very simple. Check. Current is going to come here, right? Get here. When current gets here, current is going to go this way, right? Wait. This is 0 what? Resistance here is what? 0. Please listen. What is this voltmeter measuring? Measuring the energy needed to move what? A charge from one point to another. Are you aware that we're not moving any charge from here to here? Energy are we measuring? Nothing. Voltmeter is going to measure what? 0. This is where they confuse you. Check this. Now I'm diverting. Listen, that there's so much going on in my head. No. What is the reading on the voltmeter there? What is the reading on the voltmeter? What is the reading on the voltmeter? Guys, if it's on the switch and the switch is open, it will measure EMF. But when I close the switch has 0 resistance. Now, V is IR. But my resistance is 0. 0 times current. So take note, you'll find that in multiple choice. When the switch is open, we measure what? EMF. But when the switch is closed, the voltmeter reading there will be what? 0. There's so much I wish I could find a way of transferring all the information. Eh? Transplant. Brain transplant. I'll try it with next year Matric. Paper 2, you need me. Don't worry, Kuvadi. I will deal with paper 2. Deal with it. All right. But guys, it's what I'm saying so many things because I want to cover all the areas, whichever thing I remember. Is that fine? Please try to go through, and I'm trying to show you how not to cram. Use formulas to walk through your way. All right. Okay, quickly. Resistor X is now replaced by another ammeter. What is the reading on the? So the reading on the voltmeter increase, decrease, or remain? Guys, as long as the examiner is now asking for V external. Once the examiner is asking, because if we replace resistor X with an ammeter, you know what we're doing basically? We're blocking this guy out. This guy is no longer there. What happens to the value of the total resistance? Wait, we are now removing a resistor connected. Cha-cha, where's my note? We are removing okay, this one is addition of a resistor in what? Series. What happens to the total resistance? It will increase. What if I'm now removing? Total resistance will what? Decrease. Once you get to that, oh, here's my answer. Total resistance will what? decrease, current will increase, internal voltage increase, external voltage decrease. Each point, 1 mark. Guys, is it making sense? Diagram. Okay. Try to prove that. I love it when we try to prove. Okay. Guys, do we know the value of the total resistance here? What's the value of the total resistance? We got what? 23. But this one is what? 11. So what is 23 minus 11? Lies, 12. So it means if all right, if we remove the 11 ohms, it means our new total resistance is now what? Now, what did you say? 12 volts, right? No, 12 ohms. 12 ohms. Check. E equals to I into bracket what? R plus R. Safe to use my 12 because it's the same battery. Now I don't know the current. What is my resistance? 12. The internal resistance will not change. It is still. What's your answer going to be? 12 over 13. Please check. What is 12 over 13? I equals to 12 over 13. 0, comma. Do you see it as do you see that it has increased? 0, comma 92. So when total resistance decreases, total current will what? Increase. Good. All right. But I want to give you all the formulas in between. Then we answer that one more question that I was talking about. Run through momentum. Guys, if total resistance, but it will what? Decrease, right? Total resistance decreases. I know that I and R are inversely what? Proportional. So what happens? Total current will what? Increase. Then according to Ohm's law, V is directly proportional to I. What's going to happen? Lost voltage will what? Increase. Because my current has increased, the lost voltage will what? Increase. But E equals to what? V external plus V what? Internal. Therefore, V external will what? G. This is the formula on every step. So this is what we mean by resistance current, voltage internal, voltage. Right, I want to quickly go hunt for one question. Faster we can then get into momentum, right? But I need that one I'm going to search. I won't do any other thing if I don't get this question. Happy. All right. Let me see. I'm hoping I can get it. Are you writing? Okay. Guys, I'm just running. Check a question. Ta 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 ta. Right. Let's see. I hope. Right. Crazy physics. Please tell me it's the one. This one is the one. Is this a red shift or a blue shift? This is not where I'm going. But let's answer this. No, it's very simple. Guys, it's very simple. I'm actually glad we stopped here. Learners don't know how to answer this question. A study of the spectral lines obtained from various stars can provide valuable information about the movement of stars. The two diagrams below represent spectral lines of an element. Diagram 1 shows on the Earth. Diagram 2 shows the distant star. The lines have shifted towards the blue side in diagram 2. That's all you are looking for. The lines, you see, on the Earth, do you see where the lines are? But look at diagram 2. They have shifted to the left, which is the what? Blue. If it's shifting to the blue, it is what? Towards. I'm done. My 2 marks. Is the star moving towards or away from the Earth? Towards. Explain the answer by referring to the shift. It has shifted to the blue end, which is a higher what? Frequency. Ta-da! Learners don't know how to answer those things. Maybe it's a sign that I just stopped there. Mama, give us a sign. Yes, I got it. It's the one. This one is the one. This one is the one, guys. I got it. I got it. Have you done it before? Where? Not me. I don't remember doing this question with you, but there's something I love about it. Guys, I'm going to be very fast. I promise not to be slow on this, so I need you. At all on this. Okay. 3 electrical devices, X, Y, and Z, are connected to a 24-volt battery R, as shown in the circuit diagram below. The power rating of each of the devices, X and Y, are indicated. So the X, they're telling us is what? 100 watts. Is that fine? Y is 150 watts. But what type of connection do you see? Parallel. Automatically, parallel. P-A-I-D. Current is divided, but potential difference remains what? So if it's 20 volts there, check the way I'm doing my questions. I'm interpreting immediately. 20 volts. Z, do you know I'm not putting anything on Z? The switch is open. Guys, do you know that I have my lost volt? My lost volt is 4. You need to be smart about it. What's your EMF? 24. What's V external? 20. What's V lost? 4. Making sense? All right. With switch S1 closed and S2 open, the device function as operated. Calculate the current in X. Is this a question? What do you know? You have your V. You have your power. What are you looking for? I. All right. Please always write the things you have. P is what? 100. V is what? 20 volts. What are we looking for? I. Go to your formula page. What formula? Equals to what? IV. Make sense? 100 equals to what? I multiplied by 20. What is I? 5 amps. Done. 3 marks. Check. SCOM takes light. You are done. Put the SCOM in your brain, switches off on Friday. You are finished. Calculate the resistance in Y. But do you know that by me writing that 20, I'm actually done? Because now for Y, what do I know? I know the voltage and I know the power. Power is 100. Voltage is 20. And I'm looking for what? R. What do you do? Formula page. P. 150. Thank you. 150. P equals to what? V squared over R. Are you enjoying physics? 150 equals to what? 20 squared over R, You want to give me R? 400 divided by 150. That's 40 over 15. Huh? You are wrong. 2,67 ohms. 8.2.3. Guys, do you understand that once you outlay your things, check the pace. This could be you. In exam, you'll be telling yourself, hey, look at me. Look at me. Look at me. Guys, how do we get the internal resistance of the battery? Current is divided, right? Okay. Yes, I'm listening. So already we know the current here as what? 5 amps. Do you think we can get the current here? We can by saying P equals to what? IV again. Are you with me? I'm rushing now. P equals to what? IV. Do I know my power? Yes. Do I know my voltage? Yes. So what do I say? 150 over 20, 7,5. Are you aware that the total current here is now what? 12,5A. And that's the current that's going to flow through here. That's our lost volt. What is our lost volt? 4. That calculation. V lost. Please show the calculation. 24 minus 20, which is what? 4. But I know that V lost is equal to I multiplied by what? Small letter r. Do I know my V lost? 4. Do I know my total current? 12,5 multiplied by what? R. What's your answer? 0,53. Okay. 4 divided by 12,5. 3.2 ohm. My dear learners, check 5 marks. Check 5 marks. Look at you. Look at you. Wrong for me. 5 marks. Look at you. Look at you. You finish. You want to work for ESCOM. Look at you. You tell them, guys, I can solve your problem because I got 100% in. Look at you. All right. Watch this. This is where I'm actually going. All of those were just preambles. My main aim was just that 1 mark question. Identify device Z, which when placed in the position shown, can still enable X and Y to operate as rated. Assume that the resistance of all the devices remain on. Do you understand the question? Identify device Z. We don't know what Z is. We're told X, Y, and Z are devices. But they said Z is a device which will affect the power of X and Y. Power is I times V. So Z is a device which will not change the current here. Please listen. Z is a device such that no current will pass through it. Because it must not take any of this. Z is a voltmeter. Has so much high resistance, it doesn't take any current. I don't know if it makes sense. Yeah. That's the response there. Now, good. Let's check something. If you connect an ammeter here, are you aware that it's in parallel? What will happen? I like your thought. If we put an ammeter here, all the current will come through here. Because an ammeter has low or negligible what? Resistance. Now, once we draw all the current, this thing is no longer going to be 100 watts. In fact, it will be 0. But they said we want the device to operate as rated. It means we must not affect the voltage and we must not affect the current. So this has to be it can only be what? A volt what? Meter. If it's a voltmeter, are you aware that current would not come through? By the way, these things are connected in what? Parallel. Voltage remains what? The same. What will be the reading on this voltage? 20 volts. What's our answer? Our answer is what? A voltmeter. Explain how you arrived what I just said. What will you write? A voltmeter has a high what? Resistance. Guys, are you aware that if I take a voltmeter and use it and connect, I think I did it for you when I was doing circuits, actually create an open switch. No current will flow. So a voltmeter has what? A high resistance. It does not allow the flow of current when connected in. Nice question, eh? This one is the one. I hope you got the whole idea, guys. If it's an ammeter, we're going to remove all the current from there. But this one is a voltmeter. Voltmeter. Guys at home, are you okay with that explanation? I felt it was I just remember that there's a question because I was, you know what we don't take note of when we read? We don't take note of those statements, high resistant voltmeter and low resistance. We don't take, no one takes note of it. And this is where it actually came. And you will not find any electricity question that doesn't have that statement. They all do. But we just read like Dorian Gray. I want you to check something. Check. The ammeter, do you see? Switch and the conducting wires have what? Negligible resistance. While the voltmeters have what? High resistance. The resistance is so high that no current. When we put a voltmeter there, the current will pass through, which keeps those ones, the current there in those X and Y will remain the same. Put on the table. Okay, guys, that was lovely. Did you enjoy the circuit question? But we need to find a graph, but not today. I need to touch on momentum. All right, look at this. A 400-gram ball. Guys, you stop reading. That's your grams to kilogram. How do you convert? Okay, Mpum, it's okay. Don't worry. The reason you bought your calculator was for you to do what? To use it. Moses, use it. Moses, Moses, use it. All right. A 0.4. Do you see I've changed my reading? A 0.4 kilogram ball is approaching a baseball player horizontally in a westerly direction at the speed of, please, I don't know, something just told me. I don't know what it is, but take note. Be able to convert kilometer per hour to meter per second. I just say multiplied by 1,000, divide by 3,600. That we can what? Divide by 360. We should agree. I disagree. Because it's wrong. Can we agree? Can we agree that it's wrong? Thank you. Okay. So I don't want to cram. I just multiply by 1,000 divided by 3,006 because kilo means 1,000 and hours is 3,600 seconds. Multiply by 0.78. I don't want to cram those numbers. I don't want all of those things. My head, there's too much going on in my head than for me to read. All right. Okay. Are we safe? Can we move on? Huh? Can we move on? All right. Okay. The baseball player exerts a force of 400 newtons on the ball in the easterly direction. The ball is in contact with the bat for 0.1 second. Define impulse. Please just enjoy this one. It is the product of the net force and time taken for the force to act on the object. Guys, please get your definitions in place. Impulse, F net times delta T. Now, calculate the velocity of the ball. Before we go on, can we go back to the question and try to make sense of the question? Can't you divide by 3.6? Well, you can, but I'm just saying, for me, I just don't like cramming. Right? Udefa, if it works for you, those of you that are in class today, if it works for you, it's okay. But for me, I just prefer, I don't want to cram. So I just remembered kilometers to meters is 1,000. I know it will give you the same answer. I just don't like cramming. I'm very bad at it. Okay. All right. So therefore, it will still give you the same answer. Let's quickly read this question again, guys. The mass of the ball is what? 0.4. How is the ball coming? West. The diagram explains. Is that okay? But what happens? This guy, the ball. All right. He whisks the ball. Okay. With the force of what? 400 newtons. But the force is in which direction? To the east. Ball is moving to the west. Calculate the velocity of the ball immediately after contact. Wait. What are we looking for? Velocity of the ball after. This is how I interpret my questions. I'm looking for what? Let's choose a direction. What do you want? S? It says positive. Okay. The way she's saying it, east to Saturday. Positive. Okay. West has to be what? Negative. What is the initial velocity of the ball? 40. You are wrong. You are wrong. Come, let's think. Wrong. 40 per second is wrong. Negative 40, please. Because we have decided that west is what? It's a velocity. It's a vector quantity. What is our initial? Those things are very important. Initial velocity is now what? Negative what? 40. What is the mass of the ball? 0.4. What is the time of contact? 0.1. What is the F on the ball? 400 newtons. In which direction? East. Do you see a formula here? What formula do you see? Just by writing down, things just open up. Voila. When they ask you to define, you use the definition. I don't like teaching that way. Amina is like me. What's wrong? I'll be the best examiner ever. Hey, you must know your physics. You must. This is not physics lit. You must know physics. Pure. Every concept will be tested. Today I was saying, imagine you have a car. Remember what I was saying today? I have a car, a police car, making noise, driving towards a stationary car, then runs into the stationary car, then moves the stationary car, right? But when the police car hits the car, its siren jumps off and covers a particular distance. The question would be, calculate the final velocity with which the siren hits the ground. No, 50. Do you know why? Wait. When the police car was coming, Doppler effect. Yeah, break it. When the police car is coming, Doppler effect. It collides with the car. Momentum. The thing jumps off. Vertical projectile. Beautiful. Zero. Be nice, eh? To be nice. It will not be allowed. It's level 6. All right. Do we have a formula? F net delta T equals to what? Delta P. And we know that this one is simply what? M VF minus what? VI. Are you aware that everything we have now is done? What is F net? 400. What is time? 0, 0,1. What's the mass? 0, 0,4. What's the velocity? Can I ask you a question? Should our final velocity be positive or negative? Positive. Frederick. Kuvadia says you're playing games too much. Frederick says trying to damage our brain cells. Now listen to the last word. Kuvadia says one paper, one question. All right. What is our VI? I was waiting for you. Negative what? 40. Please, everybody, quickly calculate VF for me. I hope you're learning the skill. Once you write the things you have down, it becomes very easy. Calculate. What's your answer? Your wrong answer. Come. Can somebody confirm that that answer is wrong? The answer is 60.0 meters per second. Because it says you must leave it in 2 decimal places, 6.00. It's there in the instruction. But I'm not lying. Check all the instructions. It says 2 decimal places. Why you saw? Meters per second. No, it's there. It's always there. All answers must be written in 2 decimal. Now, it's a velocity, right? Since it's velocity, it has to be a vector what? Quantity. So we need to then say, our positive was what? East, right? So this has to be east. Thank you. Guys, are we okay with the 4 marks? Young men. On the table. Thank you. Yeah. No. Awesome. Everybody. All right, let's quickly check this one. When cars are equipped with flexible bumpers, they will bounce off each other. Is that okay? During low-speed collisions, thus causing less damage. In one such accident, car A with a mass of 1,750 kilograms traveling to the right at 1,5 collides with car B of 1,450 traveling to the left. You see, I'm looking at the diagram quickly. So at once that my diagram makes sense, I leave all the statements now. All right. Measurements show that the speed of car A after the collision is 0,25 in its original. Calculate the velocity of car B. Guys, 3 marks here. What are we going to say? MAVIA plus MBVIB equals to what? MAVFA plus what? MBVFB. Is that making sense to you all? All right. Can we do our substitutions quickly? Yeah. You can. Can you substitute and get me an answer quickly? Everybody. You have 3 minutes. 3 minutes, 20 seconds. 3 minutes, 20 seconds. At 8. Five marks for everybody. No, Kuvadia, we cannot use kinetic energy. Cannot use kinetic energy. And I was about to actually go there. This is, you can only use kinetic energy when they tell you that it is elastic. Why not? Because we don't know if it's an elastic collision. So we cannot say that kinetic energy before is equal to kinetic energy after. That's why we cannot. But if the examiner specifies that it is elastic, then we can. Let's press them calculators. You are free, guys. If you are free tomorrow morning, you can join. At home. If you are free in the morning, 8 a.m., I'll be at Gibson Pillay. Pound. But otherwise, you can work on the paper I sent. Try to see. Ricardo Gibson Pillay is in Lanesha South. Talk to me via WhatsApp. I'll be in 2 schools tomorrow. I'll be in Lanesha South from 8 to 12, and I'll be at Sir John Adamson from 12:30 on. Sir John Adamson is it Ridgeway? Can I say Ridgeway? No, not Ridgeway. Can I say that Ridgeway? Regan, can I call it Ridgeway? Ricardo, are you from Sir John? Oh, Winchester. Are you from Sir John? You guys did not get a message. What's your answer? Tell him your answer. Okay. What's our answer? Guys, we must have the same answer, please. Huh? Hi, my daughter. There's 0,41. There is what? 2,61? 0, yeah? Come on. Why? What did you get? Guys, let me check where your error might be. Did you put the signs? Put the sign. So can we choose right as positive? Okay, so if we choose right as, let's be fast here, and left as what? Negative. This one will therefore be positive. What is the mass of A? 17 what? 50. What's the initial velocity? 1,5. What's the mass of B? 1450. What's the initial velocity? Negative 1,1, right? Negative 1,1. Is that fine? What is the mass of A again? 17 what? 50. What's the final velocity? 0,25. Plus, what's the mass of B? 1450. Final velocity of B. So why are we getting different answers? So what's the correct one? 0,41 meters per second to the right. Kuvadia, please don't use EK. Please. Don't use EK. Only use EK if the examiner tells you it is an elastic collision. When cars are equipped with flexible bumpers, they will bounce off each other during low-speed collisions, thus causing what? Less damage. Explain how flexible bumpers reduce. Look, it's 3 marks. I'm going to be very fast on this. This is what I'm going to say. Winners most likely always get 2 marks here. For the same delta P, that's 1 mark. For the same delta P, F net is inversely proportional to delta T. That's the 2nd mark. Same delta P, 1 mark. You cannot say F net is inversely proportional to 1 over delta T if you don't tell me for the same potential change in what? Momentum. Right. Is it the set soft? Is it the right language? Flexible bumpers. Flexible bumpers increase the time of contact. Increase the time of contact. Time of contact, hence decreasing the force of impact. What's wrong? You're not getting it. So please take note of how that answer is written, and then you get your 3rd mark there. For the same change in momentum, the net force and time are inversely what? Proportional. Okay, what's wrong? You're not getting it. Let's walk through it together. Let's walk. Maybe you're pressing something wrong. Okay, let's use my calculator here. Can we do the first one? Okay, walk with me here. Walk with me here quickly. Walk with me here. It's 1750, right? Multiplied by what? 1,5. Is that fine? Plus, what do we have? 1450 times negative what? 1. Now that's going to give us 1030. Did you get that? Now what are we going to do? We're going to subtract 17,50 times 0,25. Is that minus, what do I have? 1750 times what? 0,25 divided by 1450. Are we okay, everybody? Sorted now? Sweet. Can I move on from here? Okay. If they ask you to prove if this is an elastic or inelastic, then what do? You not momentum now. Kinetic, sum of kinetic energy before. Please don't say they are equal when they say show. Don't know. Calculate the initial first, then calculate the final. Now, if they are now equal, they say therefore it is what? Elastic. Yes, if an event is independent or not. Okay, let's check something here. A 0,005 kilogram bullet is fired horizontally into a 3 kilogram wooden block resting on a horizontal surface. The bullet remains embedded together. Once you see them together, it is automatically an inelastic collision. Okay. Which is observed to slide 0,25 meters along the surface before stopping. Stopping. Take note of the word stopping. The coefficient of kinetic friction between the block and the surface is what? 0,2. Neglect the effect of air resistance. Is frictional force an external or internal force? External. Is that okay? Because it comes from outside. external force. State the principle of conservation of linear momentum in words. In an isolated system, the total linear momentum is conserved. All right, beautiful. 4.3.1. Calculate the velocity of the block after the bullet was embedded in it. We're looking for what? The velocity of the block after. So it's basically combination. So can I then say M1, I'm not going to do this, VI1, right? VI1 plus M2, VI2 equals to what? M1 plus M2. Do you agree with me? Because it's now together as a unit. What is the mass of the thingy? A bullet is fired. Okay, 0,005. What is the initial velocity? Oh, we don't even know. Oh, nice. We need to do this question. All right. Guys, do you see that we don't know? Stuck. Stuck. All right. Beautiful. Huh? So it means we cannot use this formula. Now, you guys that are saying that when you define, you use. This examiner is my brother. Long lost cousin. Oh, it's I remember. Oh, yeah. Uzwane. That set this paper. All right, so but it's okay to always first attempt. Guys, don't force it. Some of you are going to say 0 now because you want to force the formula in. It means we need to think of a different way. Awesome. So let's reread the question quickly. It says a 0,05 kilogram bullet is fired. Is that okay? Into the block. All right. So it's definitely coming at a velocity. The block remains embedded in file. Let's write a few things. The velocity here is what? 0. Then they move together. When they start moving, there's a velocity we don't know. But it says it stops. It means the final velocity. And I am checking. I see they gave us delta x. Okay. They're given delta x as what? 0,25. We do not have the initial velocity, but we have final velocity as what? 0. Mind you, they gave us what? Friction. Of friction. Guys, this is a horizontal surface. So if I were to draw my free body, the free mass diagram, what will it look like? Now, is that fine? What do we have? Applied force. So what do we have? Friction. Okay, normal, and case. There's only one force pointing up and one. Give us friction coefficient. What do we know? Coefficient of friction is Kn, which is what? Mu K M G. What is the coefficient? 0,2. What is the mass of the block? 3. What is G? 9,8. 5, all right, so 5,88 what? Newtons. That's what we know. What are we looking for? Initial. Do you notice this is now motion? What formula do you think we should use? F net equals to MA. F net equals to what? M. What is my A? F. It's not 9,8. I was waiting for you to commit. Guys, it is not a free fall. Only use 9,8 when it is a free fall. Is that okay? But the question is now, are you aware that it's only friction? But forward motion will be considered as positive. It means our F net is what? Negative. Can we then say negative 5 comma what? 88 equals, you know the mass? What is the mass? 3 kg. Do we know the final velocity? 0. Do we know the initial? Do we know time? No. Don't know time, right? Okay. Let's quickly make a list of all our equations of motion. There's one that says delta. I want to find one without time. Yes, I have it. Vf squared equals to what? Vi squared plus 2a delta x. I'm not using delta y now. Do I know my Vf? Yes. I'm looking for Vi. Do I know a? No. Do I know delta x? Yes. But I know, check, F net is equal to what? MA. Do I know F net? What is F net? Negative 5, comma. Do I know the mass? 3. What is, I don't know A. Do you see I have my A already? Can we divide? And your A must be negative because it's decelerating. Are you rounding off? I don't want us. Okay, I don't. Listen. In order to prevent us from making mistakes, then let's round off. So we're going to leave it as a fraction. Divide both sides by what? By 3. Round it off. I don't want a rounded off value. So I'm going to use this. So what? This guy. But do you understand what I was trying to do, though? I don't want to. So if your calculator is giving you 1.96, then that's it. Right. I think we're done here, guys. If you understand physics, do we know Vf squared? Yes, please to ask. It must be a contact force. I can't be pulling you without touching you. I can't. The only force that pulls people without touching is the heart. Oh, Regan, thank you. I think we're making a mistake. There's an error that, guys, there's an error that we made. Thank you, Regan, for actually pointing that out. Guys, this is a bullet block system. Our mass is wrong. Mass is wrong. Thank you. I actually totally forgot. Right. No. Because the object was stationary at first. It only started moving. It's now heavier because of the bullet. I cannot use 3. Thank you so much. I was listening to heart stories. 3,005 times what? 9,8. Please give me an answer quickly. I want us to get this question done. But it's making sense, guys. Is it making sense to you? Right. 5,88. Yeah, that's what is given. Are we good? 5,8898. Thank you so much. All right. So can we fix this? 5,8898 negative, right? What is the mass again? 3,005A. You want to give me an answer for A, everybody? Same thing. All right. 1,96. But what? Negative. Is it making sense why it's negative? Because it's slowing down. Can we then use this formula? What's our VF? 0 squared. What's our initial? That's what we are looking for. Plus 2, negative 1,96. And what's your displacement? 0,25. Please quickly get me VI very fast. You have 2 minutes. Yes, sir. Sir, yes, sir. About 60 seconds, right? Find the square root. Yeah. Find the square root. All right, it's 0.99, right? All right, so our initial velocity is 0.99 meters per second, and that's why it was 6 marks. Very nice. What are we looking for? Was it velocity of the block? After. Since it's velocity, positive to the right. Make sense, everybody? Only now we can then go and use our momentum. That's why you should do it already. You'll be bored. You'll listen. You'll be bored. Trust me. Okay, let's leave it. Calculate the initial velocity. Now, can we use that formula now? Initial velocity of the bullet. Because now we know the final velocity of the system. This is where we bring in our momentum now. Saying M1 VI1 plus M2 VI2 equals to what? M1 plus M2 VF. Are you with me, everybody? What is the mass of the bullet? 0,005. Do we know the initial velocity? No. What is the mass of the block? 3. Do we know the initial velocity? 0. Do we know the mass added together? 0.05. How many zeros? 2. Now, what is the final velocity? Guys, are you okay with my substitution, the 0.99? 0.99 was the initial for them to move, but it is the final for momentum. It must be very large, don't worry. It's a bullet. Once they ask you to calculate, once you see a bullet, if you get 20 meters per second, please know that you are wrong. Because a bullet, if it's a bullet, 300 upwards. Yes. 5.9, 4.99. 5. Five, 9, 4, comma, exactly like that. Meters per second. Velocity. Always check. Do you see I keep going back? If it's speed, I leave my answer like that. But it says what? Velocity to the right. Guys, is it making sense to you all? So, guys, what is the saving grace? We write down what we have. We write a formula. If it's not working, we go check another. But the secret, start by writing the things that you have. Take note, if it's a velocity question, you must put down direction. So let me see what I have next here. For us now. Writing. There's a 12 marks question there, and I think I have one other question that I added. But we did some good, pretty job today. Then, so tomorrow we're spending more time on vertical work newtons. Vertical work newtons. Photoelectric effect graph. I need to do a question on graph for you. Photoelectric effect graph, photoelectric effect, electricity graph. Is that okay? So graph, photoelectric effect graph. Then we do vertical. Yes, Frederick, your hand is up. Frederick, hand is up. Okay. I'd like you to try this question for me. And this. How many marks? That's my type of question. No. No, not now, because I know if you start now, I need to save because of otherwise I would lose. As if she cares, you know. um, all right. I just want to go through for 2 minutes or 3 minutes. A pulley system with a mass piece is operated by an electric motor if the load of 120 kg vertically upwards at a constant speed. Take note of those things. With constant speed, acceleration is equal to what? O. F net is equal to 0. W net is equal to 0. Those three things are equal to 0. All right. As shown in the diagram below. The load covers a distance of 6,8 meters in 0,01 seconds. Neglect all effect of friction. Define in words the term power as applied in physics. Ability to do work. Power. Use your formula page. Power is W over delta T. What does W stand for? The work done. What does this one stand for? Per. And what is this? Okay, per unit what? And then what do you have here? Time. You're done. That's my definition. It is the work done per unit time. Right. Calculate the work done by the gravitational force on the load. That's straightforward. So basically, this question is going into work energy and power already. Save it for work energy and powers. Save it for work energy and power session. What would you do here? That's nice. Can I challenge you with this? Take a picture. I want to challenge you with that. I'm finishing now, guys. Finishing now. We will continue from here tomorrow, but please take a picture. Hey, iPhone users, you buy space, you buy phone, you buy data, you buy charger. But it's okay. I mean, you're up there. We are up here. We are down here. And, but can't you delete? All right, guys. I hope you learned one or two things. You had a lovely session. Let's pick it up from here tomorrow. I need to save my lesson now. Otherwise, it's going to be disastrous. Yesterday, it went exactly. There was no. Okay. Let's continue from here with our day 4. Please, guys, I know you are tired, but it's physics. Let's make sure we do some practice. 1 or 2 questions, especially the 4 questions I identified that I said you need to get what? 100%. All right. Lovely evening, everybody. Let's talk on the group. Thank you so much, Regan. Thank you, Fatima. Ricardo, let me send a message on the group. Okay, I'll send a message on the group shortly. Good night, everybody.